Both metals and non-metals, they combine with air. Which part of air? Oxygen. And what they form is oxides. Now let us see what is the nature of metal oxides and what is the nature of non-metal oxides. If you take a piece of coal, burn it and lower it in a jar, how will you lower it? With the help of a deflagrating spoon. What is a deflagrating spoon? It is a spoon with a long handle, so that anything you burn or if you want to put inside a jar, you can. It is nothing difficult to make. You can take the lid of a bottle, it will be something like this, and then put a wire around it and you have a deflagrating spoon. So, when you burn coal or when you burn some other non-metal like phosphorus or sulfur, a gas is produced which is an oxide. If you add water to it, you get a solution and then you can test it whether it is an acid or it is a base. You studied about acids and bases in class 7. Which test do we use? We use indicator like litmus paper. So, what you can do is, if you had burnt carbon, you will get carbon dioxide. Carbon dioxide plus water will form H2CO3. I will not give you the name just now. Now, you put blue litmus paper and what do you find? That it has turned red. Always take moist litmus paper or litmus solution. So, when blue litmus paper turns red, what is the nature? Acidic. This is called carbonic acid. Same is true for sulfur. Sulfur dioxide plus water will give sulfurous acid. Sulfur trioxide plus water will give sulfuric acid. So, like this we find that whether it is phosphorus, phosphorus will form phosphorus pentoxide and phosphoric acid. So, like this non-metals combine with oxygen to form their oxides which are acidic in nature. Now, what happens in case of metals? In case of metals, they also combine with oxygen and they form metal oxides. For example, the moment sodium comes in contact with oxygen or it is exposed to air, it forms sodium oxide. Calcium also forms calcium oxide. Similarly, potassium will form potassium oxide. You dissolve them in water. Then put this time which litmus paper? Red. And what happens? It turns blue. So, what is sodium hydroxide? It is a base. It is basic in nature. So, one chemical property of metal and non-metal is that with oxygen they form respective oxides. See, sodium and potassium are very reactive. The moment sodium is exposed to air, it starts burning or there can be fire. Why? Because in the atmosphere there is not only oxygen, there is moisture also, and sodium, when it reacts with water, it forms not only sodium hydroxide but also hydrogen. And one property and a very main property of hydrogen is that it is combustible. It can catch fire. So, it is very dangerous to store sodium. What do we do? How do we store it? If we will store it in bottle, the moment we will open the bottle, there will be fire. So, but there is a solution. You know, sodium is always stored dipped in kerosene oil so that it does not come in contact with air, because the moment it combines with water, it forms sodium hydroxide and hydrogen. And this happens at room temperature only. You don't even need to heat it. On the other hand, calcium will not combine with water at room temperature, but if water is hot, then it will. It will form calcium hydroxide and hydrogen. Similarly, iron, in rainy season, what happens to iron nail if you keep it outside? A brown coating appears on iron nail. And what is that called? It is called rusting. Now, this combination was very fast at room temperature only. This was little slow, but with hot water it happened. Even magnesium will combine with water similarly, hot water. But in case of iron, it's a very slow oxidation process, and slowly it combines and forms ferric hydroxide. But if you pass steam over iron, then the reaction will take place. Iron plus steam. So, what we find is that metals react with water. On the other hand, non-metals do not react with water. Just like sodium is a reactive metal, a reactive non-metal is phosphorus. And the moment phosphorus is exposed to air, it combines with oxygen and it can catch fire. So, whenever we want to store phosphorus, we put it in water. Why? Because it does not react with water. So, non-metals react, both metal and non-metals react with oxygen, but only metals react with water. When iron is exposed to moist air, it turns reddish brown. But when copper is exposed to moist air, it turns green. Why? Because it also combines with carbon dioxide and oxygen and water simultaneously, because all the three things are present in air, and they form copper carbonate and copper hydroxide. So, that is why it turns green. In case of silver, when it is exposed to air, it turns black, which we like to call as oxidized silver. Now, why it turns? Not because of silver oxide, but because it forms silver sulfide. When it combines with hydrogen sulfide, it forms silver sulfide. If you will pass a silver rod or silver wire through a boiled egg, after some time it will turn black because it has hydrogen sulfide. The aluminum becomes dull because of the formation of aluminum oxide. So, all metals, when they come in contact with air or moist air, they form their various compounds. Another thing that affects metals is acids. Now, in the case of acid also, they form hydrogen and salt. For example, Na plus HCl will form NaCl plus H2. NaCl is salt and it will also produce hydrogen. Na can also combine with sulfuric acid, sodium sulfate plus hydrogen. So, like this we find many of the metals, sodium, potassium, calcium, magnesium, aluminum, they combine with hydrochloric acid, sulfuric acid and nitric acid. But copper does not combine with hydrochloric acid. It can combine with hot sulfuric acid or it combines with nitric acid, concentrated nitric acid. And you know, when copper combines with concentrated nitric acid, then instead of hydrogen there is production of a brown gas. And what is that brown gas? Nitrogen dioxide. So that is why when we have to store acids, we always do it in glass bottles. In fact, even pickles and tamarind juice or lime juice, they are not stored in metallic containers because they react. The taste gets spoiled. So it is always done either in an alloy like steel or glass or ceramic, etc. So this is because of the fact that acids react with metals. Metals also react with bases. For example, they can react with sodium hydroxide, and just like acids, they produce hydrogen, which can catch fire and can also create the sound of pop. Now a very interesting experiment for you. Take a beaker, fill it with copper sulfate. Now put an iron nail in it. What will you find? There will be red color deposit at the base, and this solution will turn green. From blue it will turn green. What has happened? Copper sulfate plus iron, when they reacted, they formed iron sulfate and copper. Copper is red, so it deposited at the base. Iron sulfate is green, while here iron was grey and copper sulfate is blue. So this change in color has taken place. Now what is so significant about it? See what has happened? Iron has been able to displace copper from its compound, just like sometimes you people do. The one who is stronger just pushes the weaker one and takes the thing. The metals also do like this, and in fact they can be arranged according to their capacity to react, which is called activity series. You can also put zinc in copper sulfate, and what will happen? Again red deposit and white solution, that of zinc sulfate. Okay, very interesting. Now try the other thing. Put copper in iron sulfate. This is green, this is red or brown. What happens? Nothing. Nothing has happened. You put iron in zinc sulfate, see what happens? Again, no change. Why? Because copper is less reactive than iron, or you can say it is weaker. Similarly, iron is less reactive than zinc, so they are not able to displace. So this property is called displacement of metals. This is a very interesting and very important property of a metal, and on the basis of this, as I told you, we have been able to enlist metals, and this series is called activity series. The most reactive metal is sodium. Sodium can replace any other metal from its compound, and then of course potassium is even more than sodium, and then calcium, magnesium, then aluminum, and then so on. So this is another great thing about metals, that they can assert themselves, they can put their foot down if they are stronger than the other metal, just like human beings do.